All right, I've got 12 o'clock, so why don't we go ahead and get started. My name is Ron Fodor. I'm giving the briefing on operationalizing Zero Trust today, so thanks for joining. Real quickly, I'm going to go into a little bit of my background, and then we're going to talk about what Zero Trust is and what it isn't, why it is and why it isn't, and then how we can actually drive adoption, because it seems to be going a little bit slower than most of us would like it to go. So first of all, a little bit about me. I've got a bachelor's and a master's in computer science. I was an Air Force communications officer back before cyber was a thing, so we called it communications. Since I got out of the Air Force, I've been with industry for about 20 years now, working in a couple of different areas. And I started as a systems engineer, kind of moved my way into program management and line management, and that's where I am now. I'm an operations manager for HII. I mentioned I've got 2 computer science degrees, so this is why I've got 2 computer science degrees. My first program, my dad worked for IBM, and he brought home a PC Junior in the early 80s. I was just a little guy back then, still not very big, but I'm older. I coded my first program in 4th grade. The PC Junior came with a user manual that had a basic instruction tutorial on how to code in BASIC. And so I sat down when I was in 4th grade and went through it and coded my first Hello World program. The processor on that thing was a whopping 4.77 megahertz, the clock speed. A little bit slower, you probably could have heard it, because 20 kilohertz is kind of the upper threshold for hearing. And it had a huge amount of RAM, right, 128 kilobytes. This presentation is 2 megabytes, so just to put it in perspective. 2 years later, I got much better, and I actually coded my first role-playing game in BASIC on that same machine. I submitted it as a 6th grade coding assignment, and the teacher who was grading it couldn't grade it. He said it was too complex for him. He couldn't understand it. So that's how I knew I was kind of set on this track. So in 10th grade, things got real. I learned Pascal, and I was on a whopping 40 megahertz clock processor, SunSpark 2, and this was also part of a school project. I created a crossword puzzle generator, took a list of words in and turned it into a crossword. That was actually entered into a competition. I won first place, and it was worth like $2,000 or something. Back then, that was a lot of money. So that's what pushed me into this field. Like I said, I did a lot of coding. I was a systems engineer. I'm now an operations manager for HII. And a little bit about HII, the company I work for. The legacy of the company, as you can see on the left-hand side of the slide, is all about shipbuilding, right? We build some of the most complex, most impressive ships in the world for the U.S. Navy. Starting with, on the left side, the Newport News Shipbuilding Division. They focus on the nuclear-powered aircraft carriers, nuclear submarines, really, really impressive ships. In the middle there, our Ingalls shipbuilding site down in Pascagoula, Mississippi. They build surface combatants and Coast Guard cutters. But that's not where we stop. That's what we're known for, but we actually leverage all the legacy capabilities of our extremely complicated engineering projects on those ships and push them into the technology sector. And that's what Mission Technologies is all about, right? It's leveraging our legacy, our impressive legacy, building those amazing systems and applying them to national security solutions of very different problems in every domain. So with that, let's get into Zero Trust. First of all, this is right after lunch, so I got to get your attention and kind of loosen the crowd up a little bit. Every good presentation I've been to has a comic strip. This is no different, I hope. And so I found this one. First of all, the author and the illustrator have to be credited for me to use this publicly, so they do a pretty good job. They've got some really good comic strips out there. You can go get them and use them in white papers presentations for free. So credit to the author and illustrator. Secondly, this one really resonated with me because when I first heard of Zero Trust, I said, come on, there's no such thing as Zero Trust. It's impossible to have a system that is based on Zero Trust. I'm going to get into that a little bit later, but that's exactly what this thing kind of reminded me of. There is no such thing as Zero Trust. You can't pull it off. It's not possible. Unless you're in the ICS world, and then you're all about Zero Trust. So, what is it and what isn't it? First of all, it's a better security model than what we're used to, right? And what I mean by that is the security perimeter approach, to system security. It is going to do a better job of minimizing the effects of a compromise and preventing them in the first place. The second thing, I always hear the buzzword, right? Always trust, or never trust, always verify. That's exactly what Zero Trust is. It is a way to identify a user or an entity accessing a resource on your system and authenticate that user or entity at all times. Every single transaction is identified and authenticated. And furthermore, that access is based on additional context. So it's not just about who it is and proving who it is and what they're accessing, but what threats are out there and what new vulnerabilities are on that resource that's being accessed. What it is not, first of all, it's not a throwaway of everything we've done so far, right? There's still going to be a need for certain components like security devices, firewalls. There's going to be need for those traditional security approaches. We can't just throw all that stuff out the window. Second thing, like I talked about in the comic strip, it is not a complete lack of trust of everything on your system. You still need fundamental trust in some of the things that are happening, like your hardware. Your hardware has to work the way it's supposed to work. And if it doesn't, it's not going to work. Some of the software is the same deal, right? You cannot assume that everything works perfect. You have to assume that everything is working the way it's supposed to work. And then finally, you can't just ignore the threats and vulnerabilities out there. I mentioned that in the previous thing, the previous bullets defining what Zero Trust is. But you really need to pay attention to the threats and the vulnerabilities on your network and make decisions based on that real-time information. So here's a good graphic I put together to help visualize what Zero Trust really is. On the scale, the vertical scale there, it's basically a representation of how much implicit trust we have in users or other entities accessing a file share on our network. And I've used, a version of my own account to simulate the different types of trust we can place in how much authentication and proof we apply to the access that we grant. So on the very high end, right, I'm RFOder01. I've got read, write, execute permissions on this file share, right? That assumes that I'm a very trusted person. I'm a trusted resource accessing a system resource, and there's not much more to it than that, right? I've established my credentials, and I can go read, write, execute all day long on that thing. As you move down the trust scale, things get a little bit more interesting, right? No longer am I just allowed to read, write, execute on that file share whenever I feel like. I can now only do it within a certain time, and I must also have to authenticate for each attempt I use on that resource to read, write, or execute. And then further, that access might be based on actual threat intelligence being processed and additional vulnerability information that's being disclosed against the system that file share is actually running on. So that's a good way to kind of visualize what we mean by Zero Trust. It's the amount of implicit trust that we apply to a resource or to an entity executing on a resource. So I went out and kind of scraped the internet for all the formal publications, all the documents I could find that have been issued by the US government on Zero Trust. The sad news is this is all I came up with. So there's not a lot out there. The sadder news maybe is Zero Trust as a concept has been around for a long time, about 20 years. But you'll notice this goes back to August of 2020, 2 years ago. So we've got about 2 years worth of codified documentation on how the US government is pursuing Zero Trust. And you'll notice some of these are still in draft. So we've got a lot of work to do. But that's where I want to transition, right, is, okay, why are we doing this in the first place? And then what do we actually need to do about it? So first of all, why are we doing it? I talked a little bit about this previously. There are a lot of reasons to do it. These are 4 of them, categorized at least. And in the continued cyber attacks, everybody knows cyber attacks just are going to keep happening. They've been going on since the dawn of the internet, even before that, and they're going to continue. What's interesting about some of the more recent attacks is they're not just compromising user accounts and credentials and information, they're actually leading towards actual impacts in the real world, right? The Colonial Pipeline attack, remember how hard it was to get gas? that's a real impact. It's not just, oh shoot, my identity was stolen, which sucks, don't get me wrong, but it really sucks when you need gas for your car and you can't get it. The cloud adoption piece, cloud's another kind of cool technology that's been around for a good 20 years, but it's really, really becoming a standardized platform now, right? Amazon in the classified space with C2S, Microsoft, not just Azure, but some of their actual applications are now cloud enabled. Microsoft 365 is a great example of that. It was formally released in 2017, and they're up to 350 million users and growing very exponentially. Another driver, COVID-19, everybody's favorite virus, that one sent a lot of people to work from home. And when that happened, right, the people that were used to operating within that security perimeter in a very high trust environment now are outside of that perimeter working from home. So things like VPNs help with that, multi-factor authentication helps with that, but they're susceptible to more threats when they're not in that trusted security perimeter. And that's exactly what happened to Twitter. There were a bunch of scams, spear phishing attacks against some of those work from home employees, and some of the accounts were compromised, and it tricked a lot of people into doing Bitcoin transactions. What happened is, once that was found out, Twitter actually lost 4% of its share value overnight. As a publicly traded company, you never want that to happen. Finally, the last category, this insider threat thing. Everybody knows insider threat is real. It was a real big deal back in the mid-2010s within the Intel community, but it continues to this day. And the goal of Zero Trust is to help mitigate some of that insider threat, again, by always verifying, never trusting, basing it on context-relevant information. So some of the benefits, beyond, of course, the obvious ones, right, improved security, is specific to this idea of deploying and operating in a unified network. In the security perimeter environment, the upper left side of that screen, right, you've got to maintain very tight control over everything on your network within that trusted and privileged zone. In the Zero Trust environment, you assume there are threat actors all over the place, operating on your network at all times. You pay attention to the resources and the entities accessing those resources rather than everything on the network. And so it gives you a little bit more of that operational resiliency and flexibility that we're looking for within the warfighting domain. Some of the roadblocks, well, there are a lot of roadblocks, but I broke it down into these 4 categories that are really impeding the mass adoption of Zero Trust. The first and foremost is policy, right? As a government contractor, we have to do everything the government tells us to do. And policy is really driving that, or I should say lack thereof, is really driving us to do things the way they've always been done and preventing us from improving that security posture and moving to Zero Trust type of environment. Along those lines, funding, you can't do much if you have policy without funding. And so, as a government contractor, right, we bid against RFPs all the time. And in a cost-competitive environment, which most RFPs are, we're not going to gold plate our solutions unless the government has specifically called that out. And typically they don't do that because they don't have funding to pay for those high-end solutions. So funding has been a major roadblock in terms of adoption of Zero Trust architectures. The next thing is what I'll call inertia. That's a picture of Isaac Newton and his famous apple. The organizational inertia is such that people that have been doing things a certain way don't want to change, right? They're used to it, they know it, they've got a process, it works. If it isn't broke, don't fix it. So that's preventing a lot of the migration and the change associated with moving to a Zero Trust architecture. And then finally, I mentioned previously with the codification slide, there's about 2 years of really formal documents around Zero Trust, and there's not a lot of knowledge about it. Remember when RMF first came out, it was like, what the heck are we doing with this thing? It took a while to get expertise and actual experts to implement the RMF process. We're in that very immature phase of Zero Trust right now. There aren't a lot of experts on Zero Trust. And by the way, I'm not one either. I've just done a lot of research on it. So how do we drive adoption, given all those blocks, all those roadblocks, all those impediments, and more importantly, how do we get the benefits of zero trust? What can we do to help move that ball downfield? Oh, sorry, went wrong way. My recommendations are pretty simple, and I've only got 3 of them, so it won't take too long. But first and foremost, we need some confidence in some of the solutions that are out there on the floor, right? We need to understand them. We need to experiment with them. We need to figure out how to configure them properly. And so that experimentation and proof of the solution and its effectiveness will create this buy-in philosophy, not just for companies, but for organizations like the US government that tend to be a little bit more bureaucratic in their decision making. Furthermore, requirements and funding. I talked about this as a major roadblock to why we haven't adopted it more broadly across industry and the government. And establishing these clear sets of requirements that vendors like HII and the other companies out there that bid on these RFPs, clear sets of requirements are the key to being able to propose a solution. Without clear requirements and the funding associated with implementing those solutions, we need those things in order to move forward out of the government. And then finally, authority. I like the graphic of authority versus responsibility. I'll say, there's a lot of responsibility to make sure your network and your systems are secure, and that's everybody pointing at you and the guy with his head down saying, I messed up, sorry. That's where we are right now, right? There's not a lot of authority that's saying, we need you to do RMF, but we also need you to do this zero trust policy or this zero trust reference architecture. So once we get the authority to go ahead and do those things, and that's going to come from some of the legislation that's currently in the works. It's going to come out in those formal codified documents being published by places like NIST, places like the White House and the executive order that was released. By the way, that executive order, it doesn't require zero trust. It requires a plan to implement zero trust. We need an executive order that requires zero trust, going to that authority piece. So once we do that, once we have the adequate funding profiles, once we've got the requirements to do so with the funding behind it, once we've got the confidence in the solutions and the vendors and the products that they're selling, then that's going to help us all get to that end state a little bit faster. So I mentioned, out of these 3 things, there's really only one thing that industry can do, because we can't create requirements unless we're a CETA contractor. But even then, you need funding to back those requirements up, and we can't create funding. We can't create authority. Only the legislative department can do that. But we can experiment with solutions and build that confidence level in some of these products. And so what HII is doing, I wanted to share this last slide with you as proof of, hey, we all need to take this approach, right? So this is our roadmap, and it's based a lot on our capabilities in the company. But the one that I'm really going to highlight at the very top of the slide, other than our SMEs, we've got very smart people, some of the smartest I've ever worked with, that know the legacy frameworks that have built them. We have a contract with NIST where we actually produce the standard publications and the guidance that comes out of NIST. But we also have, and you heard it in General Barrett's speech this morning, she mentioned the big data platform quite a few times. HII and our Enlighten team, our Enlighten subsidiary, right back there in the booth, go visit them after this. They have built the big data platform for multiple services, specifically in the cyber defense domain. But the idea of having a platform that can ingest a whole lot of data and make rapid decisions on that data through analytics is exactly what we need for a policy engine, a real-time policy engine that takes all that contextual information around the entity that is trying to access a resource and says, you can access that resource based on the threat information, the actual vulnerability data, and all the other relevant information that goes into that. So we're experimenting with the BDP right now to see if we can't turn that into a policy engine that can be leveraged for those real-time decisions to allow a user or an entity to access a resource. Beyond that, at the very bottom of the slide, you'll see supporting technologies and capabilities that HII can bring to bear on the problem. And a lot of those go to the initial comment I made about zero trust. There is no such thing as zero trust. There has to be some amount of trust in the system. The hardware, right? We all run hardware. Software doesn't work without hardware. And some of that hardware might not be doing exactly what we think it's doing. Whether it's been modified, whether it's been changed, whether it's had a supply chain attack and it's not the actual hardware that we thought it was, we need tools that can validate all those things. Reverse engineering, custom software applications, and of course critical differentiators. Those are other things that we bring to bear on the problem set. But the big data platform is really where we're doing that experimentation and building confidence in the potential solutions that apply to the zero trust architecture. So with that, I wanted to thank you all for your time. I really do appreciate you all coming to listen to the briefing today. I do have about a minute or so for questions if anybody's got one. But if we can't address it publicly, again, our booth is right there, right behind us, and I'll be here for the rest of the day. So thank you.
I have a question. So where do you think most of the vulnerabilities are, whether they are in software or hardware, or it's the combination of both?
I think it's a combination of both. Sorry, for those that couldn't hear, the question is where are the vulnerabilities, software or hardware? I think there are a lot in software. There's no question about that. In my background, I know there are a lot in software. We actually manage the National Vulnerability Database for NIST, and it's got about 500,000 of known vulnerabilities in it, just that one database. So there are a lot in software. However, I served on a panel for the Defense Science Board when they were looking at hardware supply chain attacks from our adversaries. And without getting into classified discussions, I know that there are ways to change hardware, to modify hardware, and to insert exploits into hardware. So they're in both places, and that's why it's important, to make sure that you're operating both from a hardware trust perspective, but also from a zero trust software-based perspective.